Hello and welcome to this new video, and in this video we are going to progress and look at theoretical probability. So in the previous session that we looked at experimental probability. So we said that there are two types of probability. One is experimental probability and the other is theoretical probability. So in the last session, I think we all remember, we looked at experimental probabilities, and we carried out some few experimental probability examples that we looked at. So we did some experiments. Now we are going to look at theoretical probability. Before we do anything about theoretical probability, we have to first of all understand what theoretical probability is. So basically, theoretical probability is a probability that is expected to occur. So for example, when I flip a coin 100 times, I expect tails to come up 50 times and heads to come up 50 times. So meaning that the theoretical probability is half for a head and half for a tail. That is theoretical probability. Anything that is expected is theoretical probability. Let's try an example and see if we can shed more light on what theoretical probability is all about. If an avocet cone is tossed, what is the probability that it lands? What is the probability that it lands A, heads up? What is the probability that it lands B, tails up? Now, look at this. We have a cone that has two sides. One side of the cone is a head and the other side is a tail. So if I was to toss it, what would be the probability that it will land head up? Remember, our probability is defined by the ratio probability the event occurring is equal to favorable outcome over total outcome. So in this case, we are simply going to say our favorable outcome, that head will be up, is obviously 1 because there's only one head, on that particular coin. So we're going to say our event happening is head. So that will be equal to the favorable outcome is 1 over how many sides does a coin has? 2, which is 1 over 2 or half, or anything equivalent to that as 0.5 will also be accepted. Okay, so that is how we can find the probability. What is expected to happen is that the head is obviously going to land face up, or otherwise the tail will land face up. Now, how about if I wanted to show the probability of a tail? Probability of a tail is equal to the favorable outcome. On a coin, there are two sides. One side is a head, another side there is a tail, meaning that there's only one tail. So the favorable outcome is 1 over what is the total outcome, which is 2, because a coin has two sides. So meaning that the probability that it's a head, it's half, and the probability that it's a tail is also half. That is how we can understand the theoretical probabilities of an event that is obviously going to occur. Let me try another example to clear the concept of theoretical probability. This example says, what is the probability of picking a 2 from a well-shuffled pack of 52 playing cards? What is the probability of picking a 2? The first thing you have to put in mind is that when you have a deck of cards, each card in that deck is repeated itself 4 times. For example, 1, which is denoted by A in a card, in a deck of cards, comes 4 times, and 2 comes also 4 times. Each card is 4 times itself. And number 3 is also 4 times. So each card is 4 times, up to 10. From 1 to 10, and then we have K, Q, J. Now, that is important for us to understand because we are simply going to say the probability of us picking a 2 card is equal to the favorable outcome. How many 2s are in a deck of cards? There will be 4 2s. So meaning I'll say the favorable outcome is 4 over, what is the total outcome? How many playing cards do we have? 52. So over 52. Which means this can be simplified. Remember, you should always have a habit of simplifying your probability to its simplest form. We find the easiest way to simplify this. 4 into 4 is 1. 4 into 53 is 13. Because 4 times 13 is 52. Now, that is the probability of us picking a 2 in a well-shuffled pack of 52 playing cards. The probability is going to be 1 over 13. Okay, let's look at this concept here. Still going to shed more light on theoretical probability. Now, what we should put in mind is that when an event is sure that it will occur, that means the probability is 1. And when we are certain that the event won't occur, meaning that the probability is 0. So for example, I have an example here. What is the probability that the sun will rise tomorrow? It's an obvious that the sun will rise, right? Meaning the probability is 1. Now, number 2. What is the probability that 1 kg of gold will float on water? It's not possible that a 1 kg of gold can float on water. That is not possible. That means the probability is straight away as 0. So meaning the probability of all other events that are likely to take place are ranged between 0 and 1. So in general, what we are saying is that when an event we are certain that it will occur, that simply means that the probability is 1. And if we are certain that the event won't occur, that simply means that the probability for that event is 0. Let's try this example to practice what we've just discussed. A box contains 1 red ball and 4 white balls. Okay? If a ball is picked at random from the bag, excuse me, what is the probability that it is A, white, B, red, C, black, D, a ball, E, not red? Okay, so let's go through the question. We gather the information. The intel that we are getting from the question is saying we have been given a box, and in this box we contain white, red ball, which is, sorry, 1 red ball. Okay, and then we also have 3 white ones. So 3 white balls in the box. So meaning we are going to simply say 1 plus the 3, we're going to have 4. So meaning in that box, in the box, we have 4 balls. This is what it means. So now, we know that there are 4 balls in that box. But we know that 1 is, out of the 4 balls, 1 is red and 3 are white. So what is the probability that A, the question here now, that it's white when we pick at a random? Okay, what is the probability that we'll pick a white ball? Remember, probability is equal to favorable outcome So I'll use W to say white. Okay, since the first one is white, yes. The favorable outcome. How many white balls do we have in the box? There are 3, right? There are 3. So we're going to say 3 over, what is the total balls? The number of balls in the box is 4. So the probability of us picking a white ball is 3 over 4. This is for A. B. The probability of us picking red. What is the probability of us picking red? How many red balls do we have? So we say the probability of picking red is equal to, we have 1 red ball, which is our favorable outcome, over the total number of balls in the box is 4. So the probability of us picking a red ball is 1 over 4. Let's look at C. What is the probability of us picking a black ball? Probability of us picking a black, I'll just write black, is equal to, what is the favorable outcome? How many black balls do we have in the box? 0. We do not have any black ball in the box. Over the total balls that we have in the box is 4. This will give us 0. So the probability of picking a black ball is 0. Okay? The probability is 0. Now, I will take you back to what I was saying about when an event is certain that it won't occur, the probability is 0. Remember, here we said that it's not possible that the 1 kg of gold will float on water. That's why the probability was 0. So here we've been clearly informed that in the box there's 1 red ball and 3 white balls. We've not been told that there's any black ball, meaning that the event is certain that we cannot pick a black ball because there's no black ball in the box. That means the probability of picking a black ball is 0. And that is how we've found the 0. Let's look at the other question. What is the probability, that is D now, what is the probability that it is a ball? In this box, we have balls. So the probability of us picking a ball is equal to, at this time we're not focusing on the colors of the balls in the box. We are just focusing on picking a ball. So what is the favorable outcome of us picking a ball? How many balls are there? 4. So we have 4 over, what is the total number of balls in the box is 4. So meaning that will give us 1. Again, this tallies with the explanation that I was saying, when an event is certain that it will occur, the probability is 1. So at this point, it is certain that any time that we will go in this box to pick a ball, the probability is obviously a 1 because everything we have in the box, they are balls. So it's going to be a 1, we'll pick a ball. Now let's look at the other one. What is the probability that it is not red? It's a very, very good question. What is the probability that it is not red? So meaning that we need to understand one thing. What is the probability of picking red? The probability of picking red is here, 1 over 4. So meaning that for us to know the probability of us not picking red, we are simply going to say the probability not red is equal to, what is the favorable outcome of us picking a red ball? It gave us the probability of 1 over 4, which is the probability of picking a red ball. Now, what is the probability that as we pick a ball from the box at random, that ball happens not to be red? So meaning we know that, of course, as we are going in the box, there is a probability of us picking a ball. So we are going to say the event is certainly that we can pick a red ball. So we can say the probability is 1, which is possible that we can pick that red ball, minus 1/4. The 1/4 is the probability of us picking, okay, is the probability of us picking a red ball. So let me just create a space there. 1 minus 1/4. So when we subtract the probability that it is possible to pick a red ball minus the probability of us picking the red ball, what we'll get is the probability of us not picking the red ball. So the fraction is 1 minus 1/, so meaning this is also over that. So we'll say over 4, the common one. 1 into 4 is 4 times that 1 times that 1 will have 4 minus 4 divided by 4 is 1. 1 times the 1 is 1. This will be equal to 4 minus 1 is 3/4. So the probability of us not picking a red ball is actually 3/4. And you can see that the 3/4 is actually the probability of us picking a white ball. Meaning that this is actually making sense. Because if we go in this box at random and we do not pick a red ball, meaning what we've picked is a white ball. So meaning the probability should be the one for a white ball. So meaning that the probability is 3/4 of us not picking a red ball. And that is how we can calculate theoretical probability. In the next session, we'll look at how we can calculate, or we can look at how we can use tree diagrams to calculate the probabilities. Thank you for watching, and have a blessed day, and Happy New Year to all of you. Stay blessed.